In this lesson, we're going to cover Unit 6, Acquisition 1, and we are going to do one-step conversions. So the first type of conversions that I'm going to go over is converting between moles and grams. So let's say I had like 2 moles of a substance and I wanted to know how many grams that would be. So the conversion factor that we're going to use anytime that we are converting between moles and grams is the molar mass. Like if you were converting between inches and feet, there are 12 inches in every 1 foot. If we're converting between moles of carbon to grams of carbon, there's 12.01 grams in every 1 mole of carbon. That is our conversion factor. Whenever we're doing these calculations, I'm always going to say this: start with the given. There's going to be a value given to you in the question and the problem. Always start with the given. And then we are going to set up the conversion factor. So the given units will cancel. So what that's going to look like is, let's say we start with grams. The way that we get grams to cancel is by having grams in the denominator. Grams divided by grams will cancel. So moles will go up top. Whatever unit your given is, that same unit has to go in the denominator, so they cancel. Let's say you were starting with moles. Now if we are given moles and we want moles to cancel, moles will go in the denominator, grams will go in the top. Again, always setting up those units on the diagonal. If I had moles divided by moles, that unit would cancel and we would be left with grams. So let's do 2 problems. First example. How many moles of calcium chloride are in 3.2 grams of calcium chloride? So the first thing that you should do is look at the units that you are given, look at the units that you're solving for, and figure out what your conversion factor is. I'm starting with grams and I'm solving for moles. If I'm converting between grams and moles, my conversion factor is the molar mass. So step 1 is we need to calculate the molar mass of calcium chloride. So I could look up calcium on the periodic table. Its molar mass is 40.08 grams per mole. I have 2 chlorine, so 2 chloride ions, times a molar mass of 35.45 grams per mole. So the molar mass of calcium chloride is 110.98 grams per mole. Alright, so we said that you are always going to start with the given. So the problem gives us 3.2 grams. And we are going to set up a conversion. And we want to set it up so the given units will cancel. So if I'm starting with grams, grams will go in the denominator. Calcium chloride, there are 110.98 grams per every 1 mole of calcium chloride. So now the way that these conversions work, you multiply everything across the top and divide it by the bottom. So this would be 3.2 times 1 divided by 110.98. And I get 0.028834024. We have all of these decimal places. So a few things we have to do when we're recording our final answer. First, we want to determine the number of significant figures. Always look to the given. So remember, sig figs tell us how precise a measurement is. The measurement that we have is 3.2 grams. So the given has 2 significant figures. My answer could have 2 significant figures. Remember, leading zeros are never significant. So if I'm keeping 2 digits, I'm keeping the 2 and the 8. 0.02. And since the next number is greater than 5, I'm going to round up. And then lastly, we need units. Grams divided by grams cancel. And I'm left with moles. 0.029 moles would be my final answer. Let's try one more using molar mass. Let's go the other way. So this one I gave you grams and you solved for moles. What if I wanted to know how many grams of sodium carbonate are in 6.80 moles of sodium carbonate. So again, get in the habit of always looking at your given units and the units that you're solving for and figure out your conversion factor. So far, both of these we're going to use molar mass, but the next problem I'm going to show you, we're going to have a different conversion factor. So look at the given units, which are moles. Look for the units we're solving for, which is grams. If we're converting between moles and grams, we need the molar mass. Make sure when you are solving for molar mass, you are paying attention to the formula. 2 sodiums, 1 carbon, and 3 oxygens. Which gives me a molar mass of 105.99 grams per mole. So we always start with the given. Whatever value in units are given to us in the problem is what we start with. 6.80 moles. Next, we want to set it up so the units cancel. So if my given is moles, I know that moles have to go in the denominator. And per every 1 mole of sodium carbonate, I have 105.99 grams. So again, everything on the top we multiply across. 6.8 times 105.99 gives me 720.732. Let's think about significant figures. It's always going to be based off the given. Non-zero numbers are always significant. So the 6 is significant, the 8 is significant. This is a trailing 0. It trails. It's at the end of the number. A trailing 0 after a decimal is significant. This number has 3 significant figures. So for my answer, I'm going to keep 3 significant figures. The next number is a 7, so I can round up to 721. And then every answer always needs a unit. Moles divided by moles cancel out. So how many grams do we have? 721 grams. Next, we're going to continue doing some one-step problems, but for these problems, we're not going to use molar mass. We're going to use a new conversion factor. So now let's talk about converting between moles and particles. Particles can be anything. Usually what we're going to see, like atoms, molecules, ions. How many water molecules are in 3 moles? So now we have a different conversion factor. Remember in the last lesson we said that 1 mole, it's like a dozen equals 12. 1 mole equals 6.022 times 10 to the 23rd. So if we're converting between like moles and particles, the conversion factor is not going to be the molar mass, it's going to be Avogadro's number. So in this case, 1 mole is equal to 6.022 times 10 to the 23rd particles. First problem. How many moles of magnesium are in 7.5 times 10 to the 23rd atoms of magnesium? So we're going to start this problem just like our molar mass problems. First thing you want to do is look at the units that we're given, look at the units that we're solving for, and figure out our conversion factor. We're starting with atoms, we're solving for moles. Atoms is considered a particle. If I'm going between moles and particles, I'm going to use Avogadro's number. We always want to start with the given. I'm going to plug in Avogadro's number as my conversion factor, always setting up our units so they cancel. So if I'm starting with atoms, that means atoms have to go in the denominator. And I have 6.022 times 10 to the 23rd atoms for every 1 mole. One of the biggest mistakes that I notice for scientific notation calculations is you have to know how to use your calculator. So whichever calculator that you are using at home, make sure that you know how to use the scientific notation. All right, so if you have a TI-30, I recommend using the E button. It is this double capital E, and it is right above the 7. So I'm going to do 7.5, press the second button, and then you're going to see this capital E. That replaces the times 10. So if I'm trying to put in 7.5 times 10 to the 23rd, it's going to look just like this, 7.5e23. This replaces the times, 10, caret. You don't need parentheses. We're going to put it just like this, 7.5e23. Avogadro's number is in the denominator, so divided by 6.022e23. If you're using the E button, you don't need a times 10, you don't need a caret, you don't need parentheses. And I get 1.2454. We're going to look at the given to determine the number of significant figures. There are 2 of them. We only look at the one number that comes next. It's less than 5. So I do not round up. Atoms divided by atoms cancel, and we're left with moles. 1.2 moles. Let's do one more problem using Avogadro's number. So for this one, I asked you to solve for moles. Now we're going to go the other way. I'm going to give you moles. What if I wanted to know how many water molecules are in 5.5 moles of water? So step 1, look at your units. We're given moles, we're solving for molecules. Based on what we're starting with and what we're solving for, think about which conversion factor we're going to use. If I'm going between moles and particles, I'm going to use Avogadro's number. Next, when we're ready to solve, we're always going to start with the given. The given is 5.5 moles. Think about where your units are going to go so the given units cancel. I need moles to cancel. That means mole has to go in the denominator. And for every 1 mole, I have 6.022 times 10 to the 23rd molecules. Both numbers are in the numerator, so again, you multiply across the top. 5.5 times 6.022, second, E23. And I get 3.3121 times 10 to the 24th. Don't forget your times 10. All right, last 2 things. After every single calculation, you need to round to the appropriate number of significant figures. The given has 2 sig figs. My answer gets 2 sig figs. And then your answer needs units. So my final answer, 3.3 times 10 to the 24th molecules.